Welcome, software engineers, to CSC 222 Software Engineering. For those of you that want to play along, there's a little poll there. We've done this a couple times already. How much warmer is Irvine, California than Mequon, Wisconsin? Well, according to the internet, which cannot lie, it says Irvine, California is 68 degrees. Mequon, Wisconsin is 38 degrees. Oh, yeah. I should have put a new one on there. Guess what our forecast is for tomorrow? Snow. A funny thing happens after it snows in Wisconsin. Usually then the front goes through and the temperature really drops. We'll probably have some low temperatures that are 10 degrees Fahrenheit above zero. That's really cold. And if you say you don't want to be here, I don't blame you. All righty, let's actually do something, shall we? Good. Let's take a look online at Blackboard, at least vicariously. For those of you that have submitted assignment 17, that's sprint 5, if I recall the number correctly, of the individual add numbers project, thank you. I've been putting that off a little bit because a couple of folks asked some questions, but the time has come for me to actually take a look at that, and I will. But upcoming, homework assignments 19 and 20, which are both related to your team project. Both of those are due on Wednesday. One of these assignments deals with creating a document. I've entitled it an idea document because it's going to combine both requirements and specifications. So to do that document well, you need to review what requirements and specifications are all about. I'd be happy to entertain questions in a minute also on that. Now, only one member of the team needs to upload the document. I would like all members of the team to be involved in the process, but you can go through a process of selecting the person who will collect all the ideas, put them together into a finished product. The document does not have to be, this is not a 10-page document. You probably need to create a couple pages, maybe a little more, in order to do a good job. Think about the questions and answers that are necessary in both the requirements and the specifications phase. We covered those in Unit 1 of this course. And then the other assignment is to actually carry out the first sprint of the team programming project. I'm going to allow teams to decide how to break up the features and functions. As I advertised the last time we met, and yeah, it's been a week, hasn't it? We didn't meet last Wednesday. That's okay. Did you celebrate Veterans Day appropriately? Good for you. You as a team can decide what features and functions will be in each sprint. We're doing 3 sprints. This is the first one. I recognize by the time the last one's due, the middle of December, everything will be in it. So as I said last time, I encourage you to think about hard part first, or at least some of the hard parts first. This does not have to be 1/3 of all the features involved there, but you want to think about how you're going to structure things. And this is part of the Scrum process. As a team, based upon the client's backlog, my requirements, you can decide. But remember, what you're producing for this sprint is a functioning product. It actually works. It doesn't have all the features and functions. It doesn't do everything the final sprint will do. But this is not a prototype. This is not just, little bits and fragments of code. This is a product that does something. It implements some of the features and functions. In the words of Scrum, this is a potentially shippable product. So that's 19 and 20. Let me do the other ones and then I'll pause. see if you got questions. We're going to talk about CNCS 10 today. We're on this path of talking about one of the commandments, relating it to computer science, and then you reflecting on it Monday to the next Monday. So CNCS 10, giving that to you today, due next Monday. Assignment 21, I'm going to ask you to read an article online, the third of the articles that we're reading by Fred Brooks, the grandpapa of software engineering. This article is entitled Computer Scientist as Toolsmith. I'd like you to glance at it. I want to say some things about it next time. And then assignment 21 is a quiz, and that's due the Monday after Thanksgiving. So next week is Thanksgiving break. I don't really want you to do things during Thanksgiving break. Maybe a tiny bit on the sprint 2 of the team project. And this will be due the Monday right after we come back from Thanksgiving break. If, as a team, you have a specific question about what you are doing, your specific team project, I'm going to allow some time at the end for you to meet in a breakout room as teams, and then I'm going to hang around. Sometimes I say, any questions? And I count to 7, and then I say, okay, we're done, and some of you are typing or other things there. So I'll hang out for a little bit. You have specific questions about your project, let's do that at the end. But if you have a general question about either the idea document or sprint 1 of the team project, you can ask those now. Feel free to either unmute and ask, or go ahead and type it into chat. I'm going to pause. In teacher school, they tell you if you ask for questions, you have to wait 7 seconds. 7 seconds, that's a lot of dead air time. We're all uncomfortable. Not here, because we're all on Zoom, but yeah. I should know what the dates are. Today is the 14th, right? Yeah, so the Monday after Thanksgiving is November 28th. That's correct. And hopefully Blackboard gives you that date too. But we all know how good I am with Blackboard. I can hardly wait until you guys go to Canvas. Then I can learn something else. All righty. If a question comes up or in the midst of typing it, go ahead. I'll pause and we'll get to those. Otherwise, you can talk to me after class or send me an email message. Either of those is just fine. So these are the sprints. Wednesday is the 16th. That's when sprint 1 is due. 2 weeks from Wednesday, November 30th, is when sprint 2 is due. And then the final sprint is 2 weeks after that, December 14th. December 14th is in the midst of the final exam week. I haven't double checked yet when the final exam is scheduled for CSC 222. I will do that. It may or may not be on the 14th. Makes no difference. That's just when we'll do this. Speaking of the next exam, it is not a final exam. You have 3 exams. The third one is a unit exam. So same size, same format, same ideas as the first 2 exams, just covering different material, the material from Unit 3. Now, Concordia universities all over the place say that students should have a culminating final experience. That doesn't have to be a comprehensive final exam. This project, this team project, serves as a culminating final experience. We're doing everything that we've talked about in this class in the context of that project. So that will cover that. These are the dates, you know. Good. We've been talking about aspects of professionalism. My list has 10, just because I relate them to the 10 commandments, but I'm sure you can think of additional aspects of professionalism. And some of you have suggested better names for some of these. I appreciate that. I'm going to redo this, especially, oh, I don't have the first thing here, especially the being cool and calm one. But if you have what you think is a better term for any of these, let me know. I'm happy to use terms that make more sense, to be sure. My 9th aspect of professionalism is being content. Have I shared with you that I'm not always professional? Being content is a tough one, and it's also a thin line to walk. You might, thinking ahead, wonder if this relates to the idea of coveting, and it certainly can. There's not a lot of things that I do covet, but boy, there are some things that I do, and they usually relate to automobiles. I don't really covet the latest generation Corvette, the 8th generation Corvette that started in 2020. I don't. But the last of the 7th generation, the 2019 ZR1 Corvette, yeah, I covet that. I have a 1990 ZR1 Corvette, which I really like a lot. And I really like my daily driver a lot. I have a 2012 Mercedes E550, but I do covet an E63. All right. Well, enough about me. Anyone who says that they do obey the commandments is either fooling themselves or really doesn't understand what the commandments say. All right, being content. I want you to work from home for 2 days per week to reduce our carbon footprint. No, my wife and 3 small children are in that house. They're always mean to me. How bad could it be? Let me put it this way. I'm sitting in an egg carton and talking to a moron, and this is better. You can see all kinds of violations here of professionalism, but certainly one of them is being content. I do want to relate that to the 9th commandment. Now, this is the one that if you're not Lutheran really throws people, because Martin Luther broke coveting up into 2 parts. When you understand the origin of this, it really makes sense. You shall not covet your neighbor's house. Well, really, it's not house. The word that's translated house here is better understood as inheritance, coupled with the idea of a family name. Inheritance and name. So it's not just, oh, wow, that person has a split level 2-story. That's much better than mine type of thing. You had better not be coveting over there. When the commandment and Luther's explanation talk about coveting the neighbor's house, it's not a physical structure. It's the person's good name and their inheritance. We'll talk more about that next time, but you can begin thinking about it and read the CNCS 10 now. We're in the midst of Unit 3. Unit 1 was the idea of software engineering. Unit 2, the implementation of software engineering. And now Unit 3, interaction, subtitled The Power of the App. I'm not an engineer, so this might be a dumb question, but why can't we 3D print a blockchain and HTML it into a Bitcoin? What good is any system if it can't or isn't used? Whether that's because the user doesn't understand it or... So we talked last time that we met a week ago about the fifth major phase in software engineering, deployment. I shared with you a lot of different terms because they all apply. In deployment, someone will use the system. In deployment, someone will apply this app to the problem. In deployment, the thing is actually used by the client. These are really just synonymous sentence fragments for exactly the same thing. This is what deployment is all about. So we covered A, B, and C, caps A, B, and C last time. And actually we did part of D, but because it was at the very end a week ago, it might be worthwhile to review that. One thing that you learn as a software engineer is even if it's not stated in the specifications, there are a number of things that users expect, user expectations. I can relate these to the transcendentals, truth, beauty, and goodness. Even if the user didn't put in the specifications, I don't want the app to drop dead if I mistype a value. We software engineers should recognize that as a legitimate user expectation. Goodness. Truth goes without saying. If it doesn't produce accurate result, if when given valid data, it doesn't produce accurate information, then that's not a good system at all. The beauty and goodness ones, though, are certainly part of user expectations. Even if they can't articulate it, and even if they don't state it beforehand, software engineers, this is part of our task, to think ahead and recognize what would the user expect. So last time I mentioned the concepts of productivity and efficiency are just things to be expected by the user. If the user didn't say, well, add numbers, it should add those two numbers in less than 250 milliseconds. If your app takes seconds to add numbers together, users are not going to like that. The expectation is computers are fast. This app ought to be fast. It's an expectation. So last time, we ended up talking about the idea of scalability. Let me define that again. Let me give you an example, and then maybe not. I'll let you think about how that might apply to any project that you're working on. Scalability. This is not a definition, but this is a good way to think about it. What happens when many more resources are used by the system? What do I mean by a resource? Data, users, processes, comm channels, whatever. What happens to my system, my app, when many more resources are used? Here's a definition of scalability. A system that is scalable can accommodate rising resource demand gracefully without a noticeable loss in QoS. Oops, I better define QoS. Scalability. An app is scalable if it can accommodate rising resource demand gracefully without a noticeable loss in QoS. QoS is quality of service. QoS, quality of service. So, well, here's the classic example. The classic example, consider a search engine. Oh, if you'd had me before as a student, you would have heard my diatribe against companies like Alphabet, Meta, etc. I don't use that search engine produced by Alphabet. That's the Google Corporation. That's fine. You can use it. That's a-okay. Not a problem at all. I try to expunge Google from my life. It's not, I don't think it's possible. I try as much as possible. So I don't use that search engine. This is one that I use. I'm not making this up. This is a real search engine, DuckDuckGo. Anybody else use DuckDuckGo? No, you use Bing. Okay, glad to hear. I don't use that either. Okay. Now, Bing is, well, yeah, Bing is a search engine too. We're just talking about the search feature, not the web browser, but just the search feature. Well, here's an example. So you go to your favorite web search engine. How many other people are using that search engine at the exact same time as you? What do you think? 5? 50? 5,000? 50? Yeah. Lots and lots and lots. So what happens? There's two ways to think about utilization here. Number one, how many concurrent users are sitting at DuckDuckGo or your favorite search engine entering a keyword? If for whatever reason, so, some big event is happening, you know what happened at the beginning of the COVID pandemic. Everybody started searching for that. There's a huge increase in search engine utilization. How does a search engine respond? Does it slow to a crawl? You type something in, press enter, and you go, is it hung up? Is it still alive? And the other aspect is, search engines offline crawl the web looking for new sites to index and then bringing those indexes into their own servers. So as more and more sites are indexed, what's the response time of the search engine? Those are two examples of scalability. Can my search engine continue to give me adequate service as far as response time, even though they have indexed many more sites than they did last month? And maybe for whatever reason, many, many more people are using it at the same time. That's scalability. Scalability relates to something that we also talked about a week ago. So it'd be good to review this, and that's the concept of big O notation. Big O, the O here stands for order. And this is a way to compare algorithms in either time or space complexity. This is going to help answer the question, what algorithms are scalable and what algorithms are not scalable. So let's see that. O is for order, and big O, the purpose of big O is to compare algorithms in time and space complexity. So last time we saw sorting as an example. And we saw that the classic bubble sort is order n squared. And that's this line here. And this is kind of bad. Anything above here, kind of bad. Versus we saw, hey, that quick sort, which is order n log n. If we continued these lines, what we notice is the curve here for n squared rises much more steeply than the curve for order n log n. Meaning, well, If I have an order n squared algorithm, it's not very scalable. Let's say that I have, 100 items. Well, that's not too bad. But moving up an order of magnitude to 1,000, that really plays havoc with the response time. So one way that software engineers use big O notation is that will help them understand, is this aspect of my app, is it scalable or not? If I need to sort often, sort many things, you don't want to use a bad sort. You want to use a good sort. Ah, nice. We're not going to see exactly how to determine the big O of any specific algorithm. If you're interested, that's usually taught in a class on theory. And you can come to mine anytime. Okay. Next semester at Mech1, I'd let you zoom in too if you want to. Let me know. How can you estimate the big O? Well, one way to do that is to take a look at the control structures. Now, most folks say that there are 4 basic control structures: sequence, selection, repetition, and then function call. I'm going to leave function call out of it. I have the other 3 here. And you know how these work. Sequential execution is just that. Each statement is executed in order, top to bottom, 1 through n, do it. Selection, on the other hand, the choice, like the if statement, notice I'm going to do this or I'm going to do that. Iteration or repetition, notice I'm going to repeat a block a certain number of times. So one way that software engineers, if they're not concerned about coming up with an exact figure, is they'll start counting and noting the qualities of the control structures in the code. If your code is totally sequential in nature, well, it's hard to imagine that it does anything useful. But if that's the case, this has a very good, this is order 1. That's great. This, as we saw with our loop last time, a single loop is order n. How many times is it through there? And a nested loop, when you start combining, a nested loop would be order n squared. So one way to start estimating the big O is just to take a look at the control structures. That will give you an idea of its big O. And then you can look things up in a chart like this and say, oh, yeah, order n. Yeah, that's good. Order 2 to the n? No, that's bad. Scalability, big O, good. Why do I need to show you this chart again? Mainly because it shows n squared is in this horrible area. N log n is in bad. Now, realize that horrible and bad are relative. You're saying, well, we've got to find an order n. Yeah, the problem is there's no known order n sort. So what we look for is, let's find those sorts that are at least bad and not horrible. All right. So what are some other user expectations? We talked about productivity and efficiency. What are some other user expectations? Well, acceptable product. I put this down just to review what we said at the very beginning of this class, and hopefully I reviewed a couple times along the way. What's the goal of software engineering? Why are we doing software engineering? It's so fundamentally we can produce an acceptable product. meaning the information is accurate and formatted. It's truthful and beautiful. It's good. Acceptable is when the output is correct and those other expectations. It's good. It's beautiful. Oh, I just said that. Formatted means displayed in a meaningful manner. By formatting, we usually mean words that describe the output information. A $sign if it's currency. Some explanation. You don't want to just throw numbers out there. You want to ensure the user knows what those numbers mean and represent. Truthful and beautiful, formatted. I'm hearing that none of your code has been implemented. Why are you so unproductive? Your new lead developer doesn't know how to use Git, and he keeps overwriting my patches. I don't know what any of that means. Well, thank you for stopping by. Okay. Now, deployment, there are many concerns for the user. There are also a number of concerns for us. We are the developer. The software engineer is the developer. And there are a number of concerns that we have regarding deployment. And guess what? They also run around the transcendentals of truth, beauty, and goodness. Let's take a look at just a couple of the concerns that we have about deployment. Software release management and delivery. Release refers to the distribution of the product outside of the company. We're not talking about you putting it on Git and a team member being able to access it. That'd be internal stuff. Release refers to the distribution of the product outside of the company. Now, what happens if, but more likely when, different versions of a software item are available for delivery, such as versions for different platforms? Okay, here's the version for Linux, here's the version for Windows 10, Windows 11, Mac OS, whatever it is. What if you have those 4 different things available for delivery? How do you manage that? Do you need to recreate things? Do you need to repackage things? Oftentimes, software engineers have to build their software. Software building, and you've even seen that term in Visual Studio, right? Build. Software building is the activity of combining the correct versions of the software along with associated configuration items into a good executable for delivery. So it's not just as simple as we have thought about it. Okay, here's sprint 5, we're done. There's a lot of things with release management and delivery. Now, after the first time, after the first time you've delivered something, and we do need to talk about maintenance, but I'm sure you understand the idea. What if we need to update the product? Then we need to ensure that we're doing configuration management. Oh, did you catch the word management in number 1, software release management, and the word management here in number 2, configuration management? What do you say? Oh, well, there'll be another management. It won't be 3 though. The configuration of a system is the functional and physical characteristics of the product as defined in the documentation. Configuration management And I'm sorry to say that you'll see this in the software engineering world abbreviated as CM. Configuration management is identifying the configuration of a system at distinct point in time for the purpose of controlling changes to it. You're familiar with this likely with your mobile operating system releases, right? I'm sorry, I only secondarily use Android devices just on a tablet to control some other things. So I don't even know. Mine probably has KitKat on it. And that must be 200 iterations of Android ago. At least Android gives them cool names, right? In the iOS world, it's just a number. iOS 16.2 must be. No, 16.0. Nobody could do Wi-Fi on. Is it just 16.1? Well, we'll see. I think I got the article in a minute. So now, hey, you've got lots of versions of iOS at Apple. How do you keep track of all those? What is configuration management? A discipline applying technical and administrative characteristics of a configuration to control changes. We need to control changes. One at a time, please. Another developer concern is software measurement. Here, before we talked about quality assurance, we talked about QA collecting data on things, including some kind of measurement of the quality. QA does that because they need to know, do we need to change our process? Is our current process resulting in good products, or is our current process resulting in poor products? So QA is going to collect data, and notice this is something that happens after it's been released. In other words, users now are reporting issues, whether they are technically bugs, errors, or whether they are unmet expectations. Both of those are collected. Don't look at that. Every time I switch back, it wants to go ahead too. Risk management. Here's another management. Technically, there's several terms that sound about the same, but in the world of software development and other places, they're not, like risk and uncertainty. Uncertainty means I don't know. I don't have the data. Is my app going to blow up? I don't know. Risk is something you do know, but you quantify based upon a probability. So risk, you say, okay, I know full well that in this app here, as soon as the database reaches 2 terabytes, that we've got to start really using virtual memory. And now my sort algorithms are thrown all wonky. It's not scalable at that point. But I'm going to weigh that risk. I'm going to say, all right, what are the odds? The vast majority of our users won't reach a database that size. It's an acceptable risk. Risk is something you know, but it's measured by a probability. So you identify risk factors, and then you analyze the probability of that happening and its potential impact. Cool. Speaking of risk, we're in danger of sitting too long. What do you think? Should we stand up? I always think that's a good idea. All right. Synchronize your atomic watches. All right. If you've been standing up, you can sit down for a minute. If you've been sitting down, it's time to stand up for a minute. Don't go away. Just stand up. You still there? Good. All righty. It's got to be close to time, but I think I'll stand up until my watch says I've been standing for a minute. It's been a minute and 15 seconds. Still doesn't think I've been standing for a minute. I have to do jumping jacks now. 1, 2, 3, 4. Thanks for indulging me. All right. There's another concern. I have this under developer concern, but it applies to users also. What was going through the mind of the terrorist stopped by Chuck Norris? Chuck's fist. Does this violate the 5th commandment? If part of Chuck's proper vocation is law Hey, Zeke, what do you think? Will glass coffins become popular? Zeke. Remains to be seen. Remains to be seen. Glass coffin remains to be. These are actually funny, just so you know. This issue is a huge issue. Security, not only for developers, but also, of course, for users. But for the most part, the burden is on us as a developer to create secure system. Software security is engineering software so that it continues to function correctly under malicious attack. It continues to function correctly even under attack. That's the classic definition of software security. Have you heard anything about security? Of course you have. Every modern software development lifecycle will say that you should be considering issues of security throughout the software development life cycle. Now, this particular life cycle is all kind of wonky. It doesn't use our same terms, etc. But what you'll notice is from the very beginning until the very end of the software development life cycle, there are a number of different security activities. Coming up with potential cases. How might this system be abused? And that's not only a malicious third party, but what about just an accidental abuse? What requirements do we have for security? Oh, look, risk analysis. This software development the software development life cycle. Throughout this series, we'll focus on specific parts of the cycle. Here, we're examining static analysis. All right, I just ripped this out of the middle of a white paper talking about it. In our requirements, specifications, design, instantiation, we haven't talked explicitly about security, but it is absolutely something to consider. Recent article, I think last week. Windows 10 and 11 users need to be extra vigilant because hackers have discovered a new way to bypass Windows security, and Microsoft currently has no fix. As a matter of fact, there's a third party that came up with a fix, and I'm just not going to do it. They want you to download this. I'm just not going to do it. Are you familiar with the term 0 day? A 0 day or a 0 day attack is an attack, a malicious piece of malware that is just discovered. So we have no defense for it. We've just figured, oh, they're doing that? Oh, that's a 0 day. 0 days cannot be caught typically by security systems because a security system needs to know what it is looking for. The 0 day stands from a logical error in the way Windows makes a security assessment of an unknown document. Wow. Wow. Yep. Too bad. We discussed, or I at least mentioned, the SEI, the Software Engineering Institute, which is affiliated with Carnegie Mellon University in Pittsburgh. They're a software engineering think tank, and they do lots of different things and make lots of different resources available. Their CERT division in cybersecurity. CERT experts are a diverse group of researchers, software engineers, security, working together to research security vulnerabilities in software products, contribute to long-term changes in network systems, and develop cutting-edge information and training to improve the practice of cybersecurity. Yeah. So when the job interview comes up, before you go there, you'll want to take a look at this, because odds are, if you're getting a software engineering position, they're going to be asking some questions about security. At least, is this something to consider in your product? You bet. About once a year, this article is 2 years old, and it references volume 11. Volume 12 of this SSOS, State of Software Security, is out, but it's behind a paywall, and I just don't want to get it. So I'm just going to reference this one that's a little more easily accessible. Software Security Report found that over 3/4 of applications have at least one security flaw. Something tells me that the percentage has not improved greatly over the last 2 years. Veracode released this year's State of the Software Security Volume 11 report, which revealed that most applications have at least one security flaw. The report also found that software teams take about 6 months to fix half of the security flaws discovered. Whoa, that's an amazing investment. We're not talking about fixing just truth. We're talking about fixing errors when somebody tries to maliciously attack your system. That's a lot of time and maintenance. Wow. Is security important? You bet. I mentioned a term before, DevOps. DevOps is a philosophy of doing a software development lifecycle, much as Scrum is a philosophy of doing a software development lifecycle. DevOps, and we did see a little video on this, combining the development team and the operations team, the software engineers and the IT people into one unit. Why? So we can get users involved early in the process, so whatever we're creating actually meets expectations and solves their problems. So now, over the last less than 5 years, we've been talking about DevSecOps. The sec here is security. With that change comes innovation. Software makers are pushing hard to innovate. They need faster development. So accelerated DevOps and DevSecOps, including security as a core aspect of the software development lifecycle. Let me just look at one of these. What is DevOps? A compound word of development and operations. DevOps is the union of people, processes, and technology to continue to provide value to customers. Notice again this informatics concept that we mentioned before. Informatics is ensuring that we have our eye on people. And that includes truth, beauty, and goodness. It includes not only what they say, but also what they expect. What does it mean for teams? So hopefully it provides good value for the user. What's it mean for teams? Well, this idea of silo, did we talk about that before? A siloing is when the department just sticks to itself. We're not going to talk to other people. Sometimes you see this on university campuses, hopefully not at any Concordias, but where you'd have maybe two departments that have similar types of offerings. What would that be? Computer science and maybe mathematics, or maybe business. So maybe the math department offers a computer theory course, or the business school offers some, I don't know what they might be. Well, rather than everybody doing their own thing, wouldn't it be so much better if everybody cooperated? It's fine to have it run out of the business school. Is your computer science professor Tallman? Has he been consulted so they're actually doing computer science well? That'd be good. The silo would say, nope, we're just doing our own thing. Quality assurance, notice there, to coordinate, and what? And security. Yeah. So we can't have a separate QA group that only looks at what we're doing at the end. You can't have a separate security team that's only going to look at the product at the very end. What if there are flaws? What do? It needs to be developed throughout the process. To coordinate and collaborate to produce better, more reliable products by adopting a DevOps culture, along with DevOps practices and tools, teams gain the ability to better respond to customer needs, increase confidence in applications they build, achieve business goals faster. Sounds like an ad, and it actually is. Right. So DevOps, and today integrating security in that also. All right, you could look at the same thing at Amazon, but it's very similar. All right, what I want to do is I want to ensure that you have some time to meet as a team, and if nothing else, you can be sure you could set up a time when you are going to do some actual work. But we've got a little bit of time right now. And what I would suggest is you give some thought to the idea document. Look it up on Blackboard. Which reminds me, I should go there before I do that anyway. All right. Don't forget, we are in Unit 3. This is day 23. Here's the article that I want you to read, Computer Scientist as Toolsmith. Just to refresh your memory, here are some things for assignment 19, the idea document, the combination of requirements and specifications. And then, of course, assignment 20 is the actual sprint 1, working but not complete features. Assignment 21, this is the one that's due 2 weeks from today. Little quiz on that. Don't do it immediately, please, because I want to talk about it some next time. And then we are up to C and CS 10. So you should be able to see all that there. Let's, I hope this works. Just a second, got to do two things. Here's that. Breakout rooms. Now I said you should be able to sign yourself. Hold B to broadcast your voice to all rooms. Oh, I didn't even know you could do that. Oh, wonderful new feature in Zoom. I can now speak to everybody in a breakout room. So I'm going to ask you to jump into your appropriate breakout room. Hopefully you see them assigned there with the letters, and here they are. A couple teams gave me a name. I gotta remember to update this document. You come up with a name for your team, send that to me also. So what I'm going to do, you have 20 minutes to think about some things. And I'm going to hang around here. If your team or you specifically has a question, especially about either assignment 19 or 20, let me know. Unmute and say it, or put it in chat. So, are you actually able to go into the breakout rooms? I think so. All right. So at this point in time, please jump into your breakout room. By the way, when you're done, then we are done. When you're done talking as a team, we are done. Broadcast your voice to all rooms. When you're done working as a team, we're done for the day. So please ask a question if you have it. Otherwise, work together as a team. At a minimum, decide when you're going to get together next. But we've got a little bit of time here where you could be thinking about assignment 19 and also assignment 20. I'm going to be stopping the recording now. That way you could feel free to ask. So let me just say, thanks for being here. Have a nice day. Have a happy Tuesday. I will see you on Wednesday, but keep working.